Scar diagrams and correlations is what you are going to see in this lesson. Please don't forget to subscribe to the channel. Basically, we are going to start with scatter diagrams. We shall see correlations in next few lessons. So, scatter diagrams, these are graphs showing relationship between two variables. When you have two variables, you can easily draw a graph, and that graph is called a scatter diagram. So there are very three important things that are needed when you are drawing scatter diagrams. So when you are drawing scatter diagrams, name both axes. Each axis should have a starting value. So whenever you have protein, the starting value should be there for this horizontal vertical, and the starting value for horizontal. Then uniform scale on both axes. It means that when you have the difference between the two consecutive values should be the same. It doesn't mean when I say uniform scale for both axes, doesn't mean that you have to use the same scale on the scale is here, the scale should use here. No. What we mean there is that when we use from 0 to 1, 1 to 2, this scale should be uniform. So you can use here 2 centimeters to be 10, and here you use 2 centimeters to be 6. So as long as it's uniform. Uniform means from one value to the next value, from one value to the next value, the difference is the same. Not necessarily that it should be the same. So, on both axes. So regression line, we're also going to say regression line, commonly known as line of the best fit. This is commonly known as line of the best fit, and it's a line that ends almost all points. The regression line should pass through the point x bar, y bar, where x bar is given by, you sum all x values over the number of those values, and y bar is given by the sum of all the y values over their number. So this x bar y bar is called a midpoint, and always the line of best fit should pass through this midpoint. Now, the best method to draw a line of best fit is called the least square method, but we don't cover it at this level. But for you, what we are using is the idea of the midpoint. We are going to see how we get a midpoint. Let us see an example here. Draw a diagram of the data below. They give you x, they give you y. So we are going to plot x and y, x, y, as simple as that. I think you know how we plot from, of course, lower classes there. So let me start with the plotting 8 and 5. So I'm going to plot a pair. This x, y. So I have 8, then I have a 5. So this is where my point is going to be 8 and 5. So that's where my first point is going to be 5 and 3. 5 and 3 is here. For you, you all do this on a graph paper. So this is my graph paper, but the graph paper, I think you know what a graph paper looks like. Then 9 and 6. 9 and 6 is here. Then we have 2, 1, 2. We start with the x, then the y. 2, 1 is here. 2, 1. Then I go to 10, 4. 10, 4. 10, 4 is here. Yeah, 10. Then the 4 is there. Then 1, 7. 1, 7. 1, 7 is here. Then I have 7, 2. 7 and 2, which is almost there. 7, 2. Then I also have 16. 16, where is 16? 16 is here. Then I have 3, 8. 3, 8 is here. 3, then 8 is there. So now I'm done with plotting my points. There are 9 points. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now, part B, they're asking me to draw the line of best fit through the data points. Now, to draw the line of best fit, you said we need x bar and y bar. How do you get x? So these are the values of x. So you add them. Add 8 plus 5 plus 9 plus 2 plus 10 plus 1 plus 7 plus 6 plus 3. Divide by their number. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. So divided by 9. And when you try to do that, this is the value you get. So our x bar is here. Then our y bar, the same. You add these ones, then you divide by their number, and then divided. This is what I got. So you come and put. Now the scale here I used that on the value. By that I use the same scale because me I'm using 2 centimeters on both the vertical and also the horizontal. You see, I named my axes. We say you should name both axes. So this is my y, this is my x. The next point we said each axis should have a starting value. So that my x-axis, okay, my horizontal, not x-axis is starting. My horizontal is starting at 0. Then my vertical is starting at 0 also. So you miss that, you lose out there. Okay, so then we say the uniform scale. Of course, I use the uniform scale. Which scale that is? I use at 2 centimeters. I need 1 unit. So from here at 2 centimeters, that's 1 unit. Now this helps us to know what is small square represents. Remember, 2 centimeters are having 10 small squares. There are these small squares on your graph. When you have this, there are those. If these are 2 centimeters, there are these small squares there. So these are in 2 centimeters. They are 10. So it means that 10 small square. It is. They will be having 1 unit. What about 1 small square? Divide this side by 10. This side by 10. So it means that every 1 small square is having 0.1. It helps you when you are computing. So now we want to put the x bar, which is 5.7. So 5 is here. It means that if this small square is 0.1, I need 0.5.7. Means that I'm going to move 7. So when I multiply here by 7, that's when I get the 0.7. So here when you count your 7, 1, 2, 3, 4, 5, 6, 7. My 7 is here. Then on the y bar, I need 5.1. 5.1 means that we need only 1 small square. 1 small square is there. So this is where my point is going to be. So this we use a dot and we show that this is our x bar. We name it. Our x bar is 5.7, 5.1. Now it means that our line of base fit is the line that passes through this one. Now, in most cases, we make sure we see that up above it, let us draw the line of base fit. When I come, we say the line of base fit should pass through this main point. So if I draw this, you see that if I'm there, I draw it, that's the best way I can draw that line of base fit. Because it's that points are all grazing. So that is clearly how I can draw it. So this side I have 1, 2, 3, 4, 5. This side I have 3 points. It is very okay. It is very, very okay. So now I'm going to take to this point. Then this like that. So my line of base fit is there. If you want to use the line of base fit, you can use the regression line. So that's how we draw. Orange is to pass through this main point. Okay. Now here they're asking me find y when x is 4. So when x is 4, I need to find my y when x is 4. So when x is 4, mine is here. When x is 4, I need to get the value of y there. Okay, so when x is 4, I'll come here and I read off the value that I will be having. So you draw this. So when x is 4, you read like this. You want to read the value of y, which we shall be having there. So this will be the value, so it's going to be 3.4. So you can come here and say y is going to be 3.4. That will be our answer. So basically, this is how we handle the first part of drawing scalar diagrams. We are going that example about this scatter diagram.